In this video, I'll talk about inclined plane with angle of inclination. An object is placed on a ramp inclined at an angle theta. Let's talk about an example of a block sliding down the ramp at a constant acceleration. Now, here's a picture of a block sliding down the ramp at an angle of inclination, theta. What we need to do is draw all the forces acting on this block here. Now, first of all, let's look at all the forces acting on the block that's sitting on a flat surface. Here, if the block is at rest on a flat surface. Okay, so here has the flat surface and has a block. Now, first of all, how do you label the x and y axis here in this situation? The y axis is just the vertical line here, right? It's vertical. And the horizontal line here is the x axis, okay? That's how you label this for the flat surface, right? For an object on the flat surface. Now, since the object is at rest, that means there's no forces pushing from the left or right in the horizontal direction. And the block is also not moving up and down, right, in the y direction either, because it's at rest. Now, what are the forces acting on this block here? There's always a force of gravity pulling the block downward, like this. We call that F sub g, right, force of gravity. And, of course, the surface is also exerting a normal force onto the block here. So we will write this, we will draw this vector here, and that is the normal force. We call that F sub n. Okay, now, what's F sub g equal to? It's a gravity force, it's mass times gravity, mg. Now, when we want to write the equation of all the forces acting on this block, there's nothing on the x direction. So only look at the y direction here. So sum of all the forces in the y direction is equal to, now this is a positive y value, this is the negative y value. So it's normal force minus the force of gravity, like that. And then what is force in the y direction? So what's the formula for the force in the y direction? Will be mass times acceleration in the y direction, right? Equal to, now the normal force minus the gravity force, which is the mg, right? That's mg. Now we know that since the block is at rest, it's not moving up and down either in the y direction. That means acceleration in the y direction is 0. So we can put that in. Mass times 0, right, equals to normal force minus mg. And that is equal to 0. Equals to normal force minus mg. Now we can add mg to both sides. We have normal force equals to mg here, right? So that's the object at rest on the flat surface. Now, let's look at the scenario where the object is on the surface at an angle of inclination. Of course, it's also sliding down the ramp. Now, how do you label the axis here, the x and y axis? In this case, it will be like this. Because it's this way here, right? Like this way. So the x-axis will be like this. That's the x-axis. And the y-axis is perpendicular to the x-axis. That will be the y-axis. Okay. Now, what are the forces acting on this object, on this block? First of all, there's always a gravity force that's acting downward here, right? We call that F sub g. Of course, the surface of the ramp is also exerting a normal force onto this block here. And the normal force is always perpendicular to the surface that's exerting the normal force. So it will look like this. Let's call this F sub n. Now, what other forces? We know that in the example, the block is sliding down the ramp at a constant acceleration. So there's a force pulling the block down here at a constant acceleration, right? Here, this force. And the block is not being pushed. So the force that's pulling the block down the ramp is the gravity force. However, since the x-axis is like this, right? It's this way, right? And this is on the x-axis, parallel to the x-axis. So this is the gravity force in the x direction. We call that F sub gx, like that. Okay, now let's look at this here. What's the normal force equal to? Because the normal force is this way, it's not directly cancelling out with the force of gravity. It's not the same as when the object is on the flat surface. Now we know that when an object is on a flat surface like this, right? The normal force directly cancel out with the gravity force, right? If it's not moving up and down. So we have the normal force equals to mg. That means in this case, here, the normal force is not equal to mg because here, F sub g, the gravity force, is still equal to mg here. Here, this is still equal to mg. But the normal force is not equal to mg. So think about what force does the normal force directly cancel out with. It should cancel out with the force that's along the y-axis, right? Because the normal force is on the y-axis. So it should cancel out with the force here, right? So let's draw this out here. Let me use screen. Okay, so here, this one, right? And this is the gravity force, right? Because the force going this way, pulling the block down, is the gravity force. And that's in the y direction, right? That's the y-axis. This is the y direction. We call that F sub gy. Okay. So the normal force would cancel out with the gravity force in the y direction. Okay, now, how about this? We don't know what F sub gx is equal to by looking at this vector here, right? However, this is perpendicular with the normal force here. So when we draw this down, we want to draw a parallel vector to this vector down here, right? Then we can draw it like this. That is F sub gx. Okay, so what does that mean? That means we just broke down the gravity force into the x and y component, which is good here. Okay, what do we do next? The next thing we have to calculate what F sub gy is and what F sub gx is. And once we calculate what F sub gy is, we can calculate the normal force, right? Because it's equal to normal force. And if you want to calculate the acceleration of the block sliding down the ramp, you need to know what F sub gx is. So we have to calculate these two vector, right? And how do we calculate that? Okay, let's draw just the vector in a different picture here, okay? So here, so we have force of gravity, right? Going downward, right? F sub g, and then the normal force, here, F sub n, right? And force of gravity in the x direction, pulling the block downward, F sub gx. And of course, we already broke down the x and y component of the gravity force, right? Like this. So this is F sub gy, F sub gx. Okay, so how do we calculate these two here? We know that this is a right triangle, right? So here, this is a right triangle. So that's the 90-degree angle. We can try to find out the angle here, right? So that we can use trigonometry to calculate F sub gy and F sub gx. Okay. So we have to calculate the angle here. How do we figure out what the angle is here? Notice that we have a similar triangle here. So this is one triangle, and that's another triangle, right? They're similar triangle. Now let me draw this. Let's say, in red here. So this one here, With this one, I use blue then. Okay, let me use blue here, dark blue. So here, that's one triangle, as we know. And there's another triangle. Let's use this color, maybe orange. Here. Right? So a smaller triangle and a bigger triangle. And they're similar triangle. Now, what we know is this angle here is 90 degree. And this angle here is also 90 degree. That means whatever this angle is the same as this angle here. So if we say this is angle alpha, this is also angle alpha. Okay. We know that here, the normal force is perpendicular to the surface of the ramp. And of course, this vector here, F sub gy, is also straight with the normal force here, right? So that means it's also perpendicular to the surface of the ramp. So that means this angle here is also 90 degrees. So what is this angle here? Now, we can do this. We know that in this triangle here, the big triangle, or in the triangle in general, all angles in the triangle add up to 180 degrees. So angle theta, angle alpha, and this right angle 90 degrees will add up to 180 degrees. So we can say that, right? Theta plus alpha plus 90 degrees is equal to 180 degrees, right? Based on this triangle. Okay. Then look at this angle here. What's this angle equal to? Right? It's 180 degrees. And we know that this is angle alpha. This is 90 degrees. So if we subtract angle alpha and 90 degrees from 180 degrees, we get this angle here. So here, we can say that 180 degrees minus 90 degrees minus alpha is equal to this angle here. And based on this, right, this equation here, we know that this is equal to theta, right? Here. So that means this angle here is equal to theta. Right? So this angle here is equal to theta. Same as this angle theta here. Okay. Now, what do we do to calculate f sub gy and f sub gx? We can use the trigonometry. Okay, so let's start with f sub gy. Okay, so we know that with this right triangle, you can say that cosine theta is equal to f sub gy over f sub g, right? Adjacent over hypotenuse. So we can say that cosine theta is equal to f sub gy over f sub g. Multiply both sides by f sub g. We have f sub gy equals to f sub g cosine theta. But we know that f sub g is equal to mg. So f sub gy is equal to mg cosine theta. Okay, next. How about f sub gx? We can say that sine theta is equal to f sub gx over f sub g, right? Opposite over hypotenuse. So sine theta is equal to f sub gx over f sub g, right? Multiply both sides by f sub g. We have f sub gx equals to f sub g sine theta. And f sub g is mg, right? So this is equal to, now we have f sub gx equal to mg sine theta. We just calculate f sub gx and f sub gy here, right? Now let's look at all the forces acting in the x direction on the block, okay? Now notice that based on this label, right, this is x direction, right? So there's only one force acting on the block. which is F sub gx. So here, sum of all the forces in the x direction is equal to F sub gx. That's it. Now we know that the formula for the forces in the x direction is m times acceleration in the x direction equals to this, which we calculated as mg sine theta here. So equals to mg sine theta. And the mass here, we cancel off the mass here. We have acceleration in the x direction equals to g sine theta, right? If you want to calculate the acceleration of the block sliding down the ramp, this is the formula. Now next, look at all the forces acting on the y direction here. As you can see here, right, it's the normal force and the force of gravity in the y direction. But the normal force is in the positive y direction, and the gravity force in the y direction is in the negative y direction. So this is F sub n minus F sub gy. Okay, so same thing here. The formula for the force in the y direction is m times acceleration in the y direction equals to, now, normal force minus, we calculated F sub gy equal to mg cosine theta. So that is mg cosine theta. Now, notice that the block will only slide down the ramp. It will not go up and down along the y axis. So the acceleration in the y direction is 0. So m times 0, right, equals to normal force minus mg cosine theta. Now this is 0. It's equal to normal force minus mg cosine theta. Add mg cosine theta to both sides, we have normal force equals to mg cosine theta. Now notice that the normal force in the acting on the object in the flat surface, on the flat surface, is equal to mg. But the normal force acting on an object that's sitting on the surface inclined at an angle is mg cosine theta. Here. So that's the difference for the normal force. Okay, let's look at some other situations here. Okay, here. Let's say another force is acting on the block. And we will have 3 scenarios. Now, scenario number 1. That will be a force that keeps the block at rest on the ramp. Okay, so now let me draw the situation, right? Let's say here, that's the ramp, and here's the block. Now we will label the axis the same way, right? For example, this will be the y-axis and that will be the x-axis, this way. Okay, so it has angle theta. Okay, now draw all the forces acting on the block here. Now think about that. A force that keeps the block at rest on the ramp, that force could be friction force, right? That's keeping the block from sliding down the ramp. Okay, first of all, there's always a gravity force acting on the block, right? Pulling downward. Like this. Still F sub g, right? And of course, there's always a normal force exerted by the surface of the ramp onto the block, which is here, F sub n. And of course, right, there's a force pulling down the block, right? So that it goes down the ramp. And the force that's pulling the block down will be the gravity force that's pulling the block downward, right? So we call that F sub gx. Now, the difference is that, right, there's a friction force keeping the block at rest. The friction force will always act in the opposite direction of the force that's pulling the object downward, right? So it will be going this way. So it's here. So that will be the friction force. Let's call this F sub s. Okay, so here, let me label this. F sub s is the friction force. Okay. Now, same thing, we have to break down the gravity force into the x and y component. So it's like this. This is F sub gy. This is F sub gx. Okay, again, this is angle theta, right? The same situation as before we talked about. Now, let's look at all the forces acting on the x-axis here. Now, according to this label, right, the x-axis is here, right, like this. We don't have to look at the forces in the y direction here because the normal force will cancel out with the force of gravity in the y direction. So just look at the x direction here. Okay, sum of all the forces in the x direction, what's that equal to? Now, this way is the positive, this direction is the positive x direction. That is the negative x direction, right? So we have F sub gx minus the friction force, right? That's the equation. Now, notice that, right? The block is at rest. So that means the block is not actually sliding down. It's just at rest here. That's because the friction force is keeping the block not sliding down. But in that case, that means the acceleration in the x direction is 0. Right? So it's 0. And we know that in this formula, right? The formula for the force in the x direction is mass times acceleration in the x direction equals to, now F sub gx, what's that equal to? Same as this here, right? We calculated. That will be equal to mg sine theta. Yeah. mg sine theta minus, okay, we keep the friction force as it is because we want to calculate the friction force, right? Let's say, okay, and the acceleration in the x direction is 0, so we have m times 0 equals to mg sine theta minus the friction force. This is 0, and that's equal to mg sine theta minus the friction force. Add the friction force to both sides. The friction force is equal to mg sine theta. Right? Okay. Now, let's look at scenario 2. Now, scenario number 2. The diagram that I'm going to draw next will apply to both scenario number 2 and number 3. Okay? So I'm going to leave a space here. So let me write scenario number 2 here. A force that will push the block up the ramp at a constant velocity. A force that push the block up the ramp at a constant velocity. Or constant speed. Okay, so let me draw a diagram here. Now, in this case, I will draw in a different direction. So here's the ramp. And here's the block. And we label our axis this way, right? The y-axis will be the same here. Like this, right? That's y and that's the x-axis. Like this. Okay, so now label all the forces acting on this block here. Now, there's always a gravity force pulling the block downward, right? So that is F sub G. And of course, same thing, normal force from the surface of the ramp acting on the block upward like this. F sub N. Now, of course, right, there's a force of gravity pulling the block downward, right? That's the x direction, so this is F sub Gx. Now, there's a force pushing the block up the ramp at a constant velocity. A force pushing the block up the ramp here, this way, right? Like this way. Let's call this F sub P, right? So here, F sub P stands for push force. Okay, now, again, right, we have to break down the force of gravity into the x and y component, like this. Okay, here, let me write here. So that's F sub Gy, that's F sub Gx. Okay, now, of course, that's angle theta here, right? So that's also angle theta, based on what we talked about before. Okay, again, right, the block would not go up and down along the y-axis here. We don't have to look at the forces in the y-axis because they will cancel out. Let's look at all the forces in the x direction. Now, the reason why I want to draw this diagram in this way this time is because I want the push force to be in the positive x direction and the force of gravity in the x direction to be in the negative x direction here. So we know that sum of all the forces acting on the x direction is the push force minus the force of gravity in the x direction. So we can write that sum of all the forces in the x direction is equal to the push force minus the force of gravity in the x direction, right? This minus this. Okay, again, we know that the formula for the force in the x direction is mass times acceleration in the x direction equals to the push force, right? Because we want to calculate what the push force is. So we'll keep it as push force minus what's F sub Gx. Same thing we calculated here, right? Which is mg sine theta. So mg sine theta. Okay, since the block is moving up the ramp at a constant velocity, right? That means there's no acceleration in the x direction either. So acceleration in the x direction is 0. And we can put that in here. Mass times 0 equals to push force minus the mg sine theta. Again, this is equal to 0. It's equal to the push force minus mg sine theta. Okay, add mg sine theta to both sides. We have push force equals to mg sine theta. Okay, notice that the magnitude of the push force to push the ramp up, to push the block up the ramp at a constant velocity or constant speed is the same as the magnitude of the force that's trying to keep the block from sliding down the ramp. Now, without the friction force, right, the block will slide down the ramp here. Will slide down the ramp. So this is the force that's keeping the block at rest. It's the force that's preventing the block from sliding down the ramp, right? So it has the same magnitude here because there's no acceleration in the x direction. Okay, let's look at scenario 3 then. A force that pushed the block up the ramp at a constant acceleration. We can use this diagram again, right? Same diagram. Now, even the equation in the x direction is still the same, right? Again, the block does not go up and down in the y direction, so we don't have to look at that. Just look at the forces in the x direction. Same thing. It's the push force minus the force of gravity in the x direction. Sum of all the forces in the x direction is equal to the push force minus the force of gravity in the x direction. Again, right, the formula is mass times acceleration in the x direction equals to the push force minus, same thing here, right? That's equal to mg sine theta. Mg sine theta. Now, in this case, because the force is pushing the block up the ramp at a constant acceleration, that means acceleration in the x direction is not equal to 0 in this case. Then this is not equal to 0, right? So we're going to keep this. So what would be the push force equal to? That's equal to, now we arrange the equation, we have the push force equal to mass times acceleration in the x direction plus mg sine theta. Now notice that the magnitude of the push force to push the block up the ramp at a constant acceleration is greater than the magnitude of the force that's pushing the block up the ramp at a constant velocity, or just to keep the block at rest, right? So it should be larger. That makes sense. We know that the acceleration in the x direction would be a positive number, right? Because it's going up in the positive x direction. The acceleration is going to the positive x direction. So this is a positive number. That means this is larger than this. Okay. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.